All right, this is a recording about playing around with the PhET electric circuits. But before I'm going to get there, let's just look at this Google Doodle here. And they're apparently playing cricket with a sock rolled up into a ball. And then this guy over here has a kitchen tool with which he's hitting the ball. And the thing this is programmed is that they need to use the laws of physics and they need to follow the laws of physics because it needs to show that this ball is jumping here and then it's being hit correctly and then it follows the certain trajectory here, just like we would expect it. Oh, out the window, cool. And so they really have to follow laws of physics because otherwise it would look weird, right? So let's actually get to the, and by the way, there's a reason why kids around the world are playing soccer rather than cricket or something else. Anyway, let's look for PhET, P-H-E-T. It is unique. We will come up with physics, educational technology, and that's what we're looking for. They have a bunch of applets. There's two ways of getting there where I want to go. Let me scroll this down a little bit. There we go, so we can see PhET. One way is just click on it, go to the website, and then simulations and so on. But a quicker way, perhaps, is if we type in circuits or circuit, and then we're right there. There we go, Circuit Construction Kit DC. DC stands for direct current. Click on it, and it starts. And there it is. Click on this one here, or double click. There we go. And that's what I want. Okay, looks a little bit small, but you know my recording screen is relatively small. I'm going to grab a battery. I'm going to grab a light bulb, and I'm going to grab a bunch of wires like this. And I'm actually using too many wires, kind of, but there's a reason why I do that. You will see that later. Okay, close the circuit, and you will see the electrons moving. And the electrons are moving from the negative end of the battery because they are negative. They're repelled to the positive side of the battery, which is over here. We can click on the battery. We see that, I'm going to scroll this. There we go. We can see it's better now. We see that it's 9 volts. And if I increase the voltage, then the lamp gets brighter. If I decrease the voltage, the lamp gets fainter. The other way of doing this is to decrease, or I'm sorry, change the resistance of the light bulb. So make the resistance larger. Notice the electrons actually slowed down and the lamp got fainter. And when I decrease the resistance, then the brightness goes up. And that's actually what I want to do. So let me choose a value here. For example, sure, 2.0 ohms. And you see the electrons are really running around there. Okay, let's make a second circuit. I'm going to push this all over here. Notice when I do that, it actually keeps that. Whoa. There we go. That's a little easier. Okay, so I'm going to make a second circuit here. Same light bulb as before, but of course it doesn't have the same value anymore. This time around, I want to do it a little quicker, so I'm just going to use a couple of wires rather than 4, but remember I said I did have a point there. Notice that this one is quite a bit brighter. I'm sorry, fainter, obviously. It has a resistance of 10 ohms, which restricts the current, so the electrons are much slower and the light bulb doesn't receive as much energy. The other one, by the way, here, remember, has 2 ohms. I want to change this one here to, let's say, 20 ohms. And so it's relatively faint. And just remember how bright this one is, how faint this one is. I will put these two now into parallel, and you will see in a moment what that means. And what happens then is once I put them in parallel, they actually still have the same brightness to them, okay? So keep that in mind. So I'm going to take this one over here. I'm going to cut it. Pretty cool cutting tool, right? Unhook it from that, put it over here, and connect it with a couple of other wires to this one here. And notice where I connected. I connected to the same side of the battery here. This wire goes to both of them. Obviously, no electrons are moving yet because the circuit is not closed. The other side of the lamp goes to the other side of the battery. So right here. And notice there it is. And that's actually the same brightness as we had before. By the way, I don't need these others here, so I'm just going to hit the delete button. So it's the same brightness before. All the lamps, all the appliances in your household are wired in parallel so that if one of them gets disconnected or you flip a switch, the other one is still on, right? if one light bulb is on in one room and you turn a light bulb off in another room, you still want the first one to be on. So everything is wired in parallel. And the same thing goes with appliances like the stove and the microwave and the refrigerator. If one of them is on or off, then the other ones still need to be on if you want them. So it's all wired in parallel. Now, once in a while, you figure out something in your household that is actually wired in series. And let me show you that one respectively. That will be your task. Remember that this light bulb is the brighter one, and this light bulb here is the fainter one. The fainter one has 20 ohms to it. That's what we change it to. This one here has 2 ohms to it. That's what we change it to. Okay, I'm going to unhook the connections. Okay, this is the fainter one, remember? This one is the brighter one, remember? Okay. Okay. Take the battery over here. Battery hasn't changed. Connect here. Connect here. And then I have one more wire which connects them from here to here, but I'm not going to connect them myself. You have to do that. Remember that this was the brighter one, right? This was the brighter one. This was the fainter one. Now we're hooking them up in series. Figure out what happens. And then when you have figured that out, you can still play all kinds of things with this cool applet. Have fun.